Welcome to this presentation on declarative versus imperative languages, where we will explore two fundamental programming paradigms. In this presentation, we will go through key concepts, differences, and examples to understand when and why each paradigm is used. Let's begin with a quick overview of what we will be covering. Our objective today is to understand the differences between declarative and imperative programming. We will also explore real-world examples and use cases for each paradigm to help you understand how they shape the way we write code. Imperative programming focuses on how a task is performed using a sequence of statements. In this paradigm, you tell the computer exactly what steps to take to achieve a specific outcome. It emphasizes control flow and changes to program states. Common imperative languages include C, C++, Java, and Python. Declarative programming, on the other hand, focuses on what the program should accomplish rather than how to achieve it. In this paradigm, you describe the desired outcome and the system or framework handles the execution details. Languages like SQL, HTML, Haskell, and Prolog are declarative in nature. Now, let's compare the key differences between two paradigms. Imperative programming requires you to specify how to perform each step, while declarative programming focuses on what needs to be done. In imperative programming, control flow and state changes are explicitly defined, whereas in declarative programming, these are abstracted away. Here's an example of imperative programming in Python. In this example, we explicitly define the steps to sum a list of numbers by iterating over each element and updating the total sum. This shows how imperative programming focuses on describing the sequence of operations required to achieve the result. Now let's look at an example of declarative programming in SQL. Here, instead of specifying how to iterate through the numbers, we simply ask the system to give us the sum of the numbers. The system decides how to compute the sum, allowing us to focus on what we need, not the implementing details. Imperative programming is ideal for tasks that require fine-grained control over the execution. It's commonly used in system-level programming, game development, and performance-critical applications where the programmer needs to control exactly how operations are performed. Declarative programming, on the other hand, is best suited for tasks that focus on outcomes rather than the process of achieving them. For example, database queries, web page markup, and logic-based tasks benefit from declarative programming. It abstracts away much of the complexity, making the code easier to maintain and understand. Some advantages of imperative programming include the ability to optimize performance and have fine-grained control over the system. However, these advantages come at a cost. Imperative code can become complex and harder to maintain, especially in large systems. Declarative programming offers a simple, more abstracted approach. It, it's easier to read and maintain since the focus is on the end goal rather than the process. However, this approach may lead to less control over the execution and in some cases can be less efficient for complex tasks. Many modern programming languages combine both paradigms to offer flexibility. For instance, in Python, we can write declarative SQL queries within the program and In frameworks like React, we use declarative UI components but may write imperative logic to manage data and events. This hybrid approach allows us to get the best of both worlds. In conclusion, understanding the distinction between declarative and imperative programming is essential for choosing the right paradigm for a task. While imperative programming provides more control over execution, declarative programming allows for cleaner, more maintainable code. Modern languages often blend both paradigms to suit different needs. Thank you for your attention. Now I'd be happy to answer any questions you may have.